This video takes a look at Module 2, Lesson 14, converting rational numbers to decimals using long division. Down here, you're just going to see three important vocabulary words you're going to need throughout the lesson, with long division being the most important probably out of these three. We are going to be using this long division algorithm a lot in this lesson. So today you guys are going to use the long division algorithm to represent fractions as decimal numbers that either terminate means end, or repeat. You know you have this when you are able to correctly and fluently use the long division algorithm to correctly represent fractions as decimals. And our standard is 7NSA2D. Convert a rational number to a decimal using long division, and know that the decimal form of a rational number terminates in zeros or eventually repeats. So with lesson 13, what we did is we took fractions and we got them with a denominator of 100 in order to convert them into decimals. In this lesson, we're going to come up with another strategy for numbers where the denominator isn't very easy to convert into a base of a power of 10. Previously, we used maybe exponents or something like that. But I'm sure from lesson 13, a lot of you are realizing it was kind of a complicated process. So today we're going to look at using long division. With that said, we're going to start with example 1. I want you to use the division button on your calculator, and you're going to find each of these quotients. So 1 divided by 2, 1 divided by 3, so on and so forth. You're going to write the answers next to each fraction, the decimal representations next to each fraction. If you want to explore additional fractions, you can, but I do want you to go through and do these 10. Then after you do these 10, hopefully you noticed a pattern. And I want you to explain for part B what two types of decimals you see. Like if you can categorize decimals into two categories, what would that be? When you are done with A and B, come back and check the video. For example 1A, what you see here are the numbers you should have gotten in the calculator. So take a quick look at those. What I want you to notice is anyone that I saw that was really long, I stopped at one point and I just put an ellipses, which are the dots, that shows that this is not all of the number that I wrote, okay? So what two decimals did you see? Some of the decimals stop, or what is called terminate, like 1/2 here or 1/4. And some of the decimals keep going and they filled up the entire calculator, like 1/11 or 1/9. So with that said, what I want you guys to do down here for example number 2, you are going to organize these 10 fractions that we had and their corresponding decimal representation. So you're going to write, like if I wanted to categorize this, you would write 1/2 equals 5/10, that entire equation there, into the correct column. Now, keep in mind, terminating means stops. Non-terminating means keeps going. So you're going to basically recopy each of those 10 that are up here into their correct category. And then what you're going to do is write what do these terminating fraction or decimals, have in common, and what do these non-terminating decimals have in common. When you are done with example 2, come back and check the video. For example number 2 on the left here, you will see our 5 decimals that terminate or stop. And what I notice is each denominator is a product of only the factors 2 and or 5. So for instance, 1/2, the denominator is 2. All right, 2 times 2 is 4. Now we have 5 here, and then 2 times 2 times 2, meaning 2 to the third power, gets 8. 5 times 2 gets 10. Now, if I look over here to the right, these are our non-terminating decimals because they keep going on and on. And each denominator here contains at least one factor that is not 2 or 5. So, for instance, 3 would just be 3. 6 would be like 3 times maybe 2. Um, and that pattern continues down here. So it seems that if the denominator is a product of only 2 and or 5, the decimal will terminate. Whereas if the denominator contains a factor that is not 2 or 5, it seems to be non-terminating, meaning that it will keep going on and on. With example number 3 here, we're really going to start getting into the meat of this lesson and our goal for the lesson, which is being able to convert fractions into decimals through long division. Now, based on what I just saw, or the pattern we just noticed, I know this decimal will terminate because my denominator is a 4. 2 times 2 gets 4. Now, also, because the fraction is negative, my decimal representation will also be negative. Okay? Remember, converting from a fraction to a decimal is just changing kind of the form it's in. So if it's negative as a fraction, it needs to be negative as a decimal. Now, remember, this number in the denominator is the divisor. It goes outside. The number that is the numerator is called the dividend, and it goes inside. Okay? Now, I know my whole answer will be negative, so I'm just going to put a negative side out front here. Now, 4 goes into 3 0 times. Okay? 4 times 3, or 0 times 4, excuse me, is 0. You subtract, you get 3. Now, because I have a remainder, you add a decimal, you add a 0, and the decimal goes straight up here too. You bring this down. Okay? Now, we're going to keep going until either A, we notice it just repeats, or B, it stops. It terminates. We have no remainder left. All right? 4 goes into 37 times. 7 times 4 is 28. Subtract here, get 2. Now I have to bring down another 0 because I still have a remainder. 4 goes into 25 times. 5 times 4 is 20. And we subtract here, and you have no remainder. So this negative 3/4 as a decimal is negative 75 hundredths. You can convert any fraction to a decimal through long division. Now, remember, this is negative 3/4. We should be able to write this. We should be able to go here to here immediately. But this example is just showing you the use of long division algorithm can get you from the fraction to a decimal without the need of getting a denominator that is a power of 10. With that said, I want you guys to go through and do exercise 1. So set up your long division. Remember, if the fraction is negative, your answer in a decimal form should be negative. And the denominator goes outside, the numerator goes inside. If you need to, you must add a decimal and a 0, and then keep bringing down additional zeros until it terminates or repeats. When you're done with exercise 1, come back and check the video. Before we look at exercise 1, I have here just kind of a little bit of a neater version of the long division. So if it helps for you to look at this, for example, 3, instead of this, it's here for you, so you can take a quick look over that. Now, for exercise 1A, you should have got negative 875 thousandths. Notice the long division here. So if you messed up, try and figure out kind of where you went wrong. And then even try to redo it to make sure you get to the correct answer. Notice once again the denominator, the 8, goes outside, the numerator goes inside. My answer should be negative because the fraction is negative. So the decimal for sure should be negative. For B, down here you see the long division. This is obviously going to be positive because the fraction is positive. You should get 1,875 10,000ths, right, like this. So this one's going to cause you to bring down a zero quite a few times, but it does eventually terminate because 2 times 2 times 2 gets 8 times another 2 gets 16. So you can get to 16 by multiplying 2 over and over again. So that's going to get a terminating decimal. For the first one, 2 times 2 times 2 gets the 8, so that tells you that will terminate as well. Now, we're going to use our long division to find the decimal representation of 1/3, excuse me. Now, this will not terminate. Now, I know that because this denominator is not a product of the factors of 2 and 5. 2 times nothing, no other whole number, gets 3, right? And 5, similar, same exact thing. So this is not going to terminate. What we are going to do is we are still going to put the denominator, the divisor, on the outside, and the numerator, which is the dividend, on the inside. Now, 3 goes into 1 0 times. 3 times 0 is 0. You subtract, you get 1. You're going to add a decimal and bring down the 0 because we have a remainder. 3 goes into 10 3 times. 3 times 3 is 9. 10 minus 9 is 1. Bring down the 0. Now, what I'm already beginning to notice, 3 goes into 10 3 times, is we have this repetition happening, right? I keep getting a remainder of 1, and I keep bringing down a 0. So, once this happens, if you notice a repetition, you can just put a line over it. So, 1/3 as a decimal can just be written like this. Because that 3, that line over top indicates it will keep repeating. But whether or not the fraction or the decimal form of the fraction will terminate or keep going, you can still use long division to take it from a fraction to a decimal. So with exercise number 2 here, we have 4 instead of 2. All of these are going to be non-terminating, meaning they're going to repeat because their denominators here are not products of just 2 and 5. So go through and do that long division. When you notice it repeating, you put a bar over the shortest sequence of repeating digits. So 3 is the only part that repeated. So the bar went over 3. If I had something that was like this, 1 6 1, oops, sorry about that. If I just had these 16s repeating, you would write it as this. And the line would have to go over the 1 and the 6 because both of them are repeating. So just make sure you are putting the line over anything that is repeating, the shortest sequence of repeating digits. When you're done with exercise 2, come back and check the video to make sure you did it correctly before moving forward. Exercise 2, we're going to start with A and B. With A, this 4 seems to be repeating. The remainder keeps being 4. So this is the decimal representation. Notice the line over top of the 4. Also notice that the decimal version is negative because the fractional value is negative as well. For B, the 0 and the 9 keep repeating. So the line should be over both the 0 and the 9, not just one or the other. And once again, it should be negative because the fraction is negative. This is an alternating pattern of repetition here of 0 and 9. C took quite a bit of work. because it doesn't repeat till after 1, 2, 3, 4, 5, 6 digits. Then, so it goes 1, 4, 2, 8, 5, 7, then 1, 4, 2, 8, 5, 7 again. So you had to extend this one pretty far out before you saw the repetition. So the line needs to go all the way over all of these numbers because this is the pattern that repeats. The 1, 4, 2, 8, 5, 7 goes over and over again. The line goes over the whole, all of these digits. And notice it's positive because the fractional representation is positive. D will be negative because the fractional representation is negative. And the part that repeats here is the 3. So the line, the bar, is only going over top of 3, not 8, because 8 doesn't repeat. It just appears one time. Now, for example 5, I want you to take these notes down. Example 5 is just asking kind of, how do we know, determine whether the decimal representation of a quotient of two integers with the divisor not equal to 0 will terminate or repeat. If we use the division algorithm, if there's no remainder, the algorithm terminates, obviously, right? Because that's when you stop using the algorithm, is when you end up multiplying and subtracting, and then there's no remainder. Now, if the value of the remainder is not 0, it is limited to just whole numbers all the way up to the one less than the divisor. D minus 1, where D is the divisor. Okay? So, for instance, if your divisor is 60, the highest or the greatest remainder you can have would be 59. You can't have a remainder that's greater than your divisor, because that just means you could have divided in by a greater value. Okay? So what that means is that the value of the remainder must repeat within that number of steps. For example, if you have a divisor of 9, the remainders are limited to 1 through 8. 9 minus 1 gets 8, and you can go all the way down to a remainder of 1. So the remainder must repeat within 8 steps because there's only 8 possible numbers here. When the remainder repeats, the calculations that follow will also repeat in that same pattern, causing a repeated decimal. So that's just another pattern, diving a little bit deeper to hopefully put additional tools in your tool bag to determine really how long should this terminate or repeat, or how long should I go before I realize there's termination or repetition. If there is repetition, how long may it take before it starts to appear, until that repetition starts to be obvious. Now, what I want you guys to do is go through and answer example 6. So example 6 is having us apply our skills of this long division of rational numbers into word problems. So go through, answer A and B, and come back and check the video when you are done with example 6. For 6A, example 6A, should have got $1.60. Eric and his 4 friends, keep in mind that is 5 people, and you are taking these $8 and you are splitting it amongst 5 people. So 5 goes on the outside, 8 goes in the inside. You should have got $1.60. Keep in mind I added the 0 here because this decimal terminates, but because it's money, you always write up to the hundredths place, so I added the 0 in. Now, for B, the answer is $2.67 per person. Now, what I did first is, because 2 of his friends can't go, we now have this problem. We have still the $8 tolls, but now there's only 3 people going. This decimal does not terminate. It keeps repeating. It is 2.666666 over and over again. Now, what you see here is if I say each friend pays $2.66, I multiply it by 3, you get $7.98. So we're 2 cents short of the $8 that are required. So each person actually needs to pay $2.67 to. Now, we'll be a little bit over that way, but we definitely don't want to be under when we're paying our tolls, because then we obviously can't go through the tolls. So each person would need to bring 267, not 266. 266 would be a little bit too short because this is a repeating decimal, not a terminating decimal. Now for our lesson summary. All rational numbers can be transformed into terminating decimals or repeating decimals using the long division algorithm. Now we can represent repeating decimals by placing a bar over top of the shortest sequence of repeating digits. So this lesson is really focused on going through and practicing using that long division algorithm. Lesson 13, like I mentioned earlier, talked a little bit about getting a powers of 10 denominator, but this is a strategy that would work for all kinds of denominators, and often it's quicker. So for this problem set, I want you to go through and convert each of these fractions into their decimal form and then pick the one that is not like the others and explain why it is different. In addition, there is an enrichment that I am requiring that you do. So you're going to go through and just think of the enrichment as an extension of the problem set. Do questions 2 and 3 here. When you are done with the problem set and the enrichment questions, come back and check the video, and that will wrap up this lesson. First, we're going to take a look here at our problem set. I'm going to scroll down slowly, so if you need to pause to just make sure you have them correct, please do so. Notice the location of the bars. You're going to have a lot of repeating decimals here. In fact, nearly all of them are repeating. Obviously, you can just set up division to solve for all of these. Also, ones like 1/3, you've probably seen before and you probably knew that one immediately. Also, if you took time to simplify any fractions, you may have noticed they simplify to similar answers, so you didn't have to do the problem multiple times. So, for instance, 4/6 is the same thing as 2/3, which is the same thing as 6/9. So they're all going to get this 6 that's repeating. So just make sure you have all of these correct. Now, the one that's different is this one. 3/6 was a terminating decimal because 3/6 in its simplest form is 1/2. The numerator and denominator have a common factor of 3, which can divide out, which would create that denominator of 2. And we know a denominator of 2 will terminate. So the 3/6 is the one that's a little bit different. Now, for enrichment 2, Aubrey should not believe Chandler. The divisor of 17 is a prime number that does not contain factors of 2 or 5. So it can't terminate. Immediately, you should know that 17 in the denominator is going to produce repetition. Now, if you took time to actually do the long division, it goes all the way out to 16 digits before it starts that repetition because remember that D minus 1, 17 minus 1 gets 16. So it repeats after the 17th step finally produces that repeated remainder. But should Aubrey believe him? No. And your explanation could really just stop at this point. 17 is a prime number. It doesn't contain factors 2 and 5. The denominator, therefore, is going to cause this fraction to not terminate. Now, 3a, just take a look at this table. Make sure you have this done correctly. Make sure your bars are over the correct digits. Now, a pattern here, the two digits that repeat in each case have a sum of 9. That was kind of a hard one to locate, but hopefully you did. As the numerator increases by 1, the first of the two digits will increase by 1 and the second one decreases. So we have 0 and 9. Then the next one, we have the 1, 8, 2, 7, 3, 6. That first digit, the digit in the 10th place, is increasing by 1, as the digit in the 100th place is actually decreasing by 1. So that's a cool little pattern that happens there with a denominator of 11. Now, for B, with a denominator of 99, the two-digit numerators in each of the fractions is the repeating pattern. So, for instance, here, I just look here, the 10 over 99, the 10 is what's repeating. The 77 over 99, the 77 repeats. So, really, the 7's just repeating. But whatever that numerator is over top of 99, that seems to be what is repeating. So A and B have you really looking at some pretty cool patterns with 11 and 99. Now, other rational numbers that follow similar patterns, there is a bunch. I mean, you could have just did like 7 over 99, any number over 99. A similar pattern, if I have something like, I don't know, let's do 821 over, let's do 999, you're going to notice a similar pattern there as well, where the 821 keeps repeating. So really this enrichment is all about pattern notification. And if you can notice this pattern, that's just additional tools in your tool belt. So you have multiple strategies to attack problems and you can attack them more efficiently. So that's basically the end of this lesson. Your goal and what you should be able to do is understand A, that you can take any fraction into a decimal through long division. But B, you should know how to do that long division. You should know that the denominator is the divisor. It goes on the outside. The numerator is the dividend. It goes on the inside. You should know about adding decimals, zeros, and bringing it down. And you should be able to ultimately say whether it terminates or repeats and use that repetition bar correctly. So, if you're able to do those things, you have mastered this lesson and you're ready to move forward.